So now we've got some interesting situations in which we want to be able to evaluate a composition of different functions. Like, let's try this. We're told to find the arc cosine of the tangent of pi over 4. Well, the best way to approach one of these kinds of compositions of arc trigonometric functions, the inverse trig function, and another function, is to work your way from the inside out if possible. In this case, let's talk about it. We've got the tangent of pi over 4. What is the tangent of pi over 4? Well, that we recall, let me get a pen working here, that we recall the tangent of pi over 4 is the ratio of the opposite to adjacent side of the angle pi over 4, which we happen to remember is equal to 1. So what we're really saying here is that we're evaluating the arc cosine of 1. So now we ask, okay, well, where is cosine equal to 1? What angle is it whose cosine is equal to 1? And if we recall from an earlier discussion, we said that arc cosine value is equal to 0. So therefore, the arc cosine of the tangent of pi over 4 will equal 0 as well. Well, how about this next one? Sine of the arc cosine of radical 3 over 2. Again, the best way to work here, to my mind, is to work from the inside out. So let's talk about the arc cosine of radical 3 over 2. Arc cosine of the radical 3 over 2 is the kind of function that's going to give us an angle whose cosine is positive radical 3 over 2, which means that we have to get an angle somewhere on the interval from between 0 and pi whose cosine is radical 3 over 2. Well, in this case, that angle has to be pi over 6. Pi over 6, right? Again, that's the only angle on the interval from 0 to pi whose cosine is positive radical 3 over 2. So what we're doing, in fact, is taking the sine of pi over 6. And we know that sine of pi over 6 is equal to 1/2. Therefore, the sine of the arc cosine of radical 3 over 2 is equal to 1/2. Well, let's just continue down the line right here. Arc sine of negative 1/2. Well, we would be looking for an angle whose sine is, let's see, an angle between negative pi over 2 and positive pi over 2 whose sine is negative 1/2. What is that? Well, in this case, we would have to say that that angle would be negative pi over 6. See example B up above here, right? If the sine of pi over 6 is 1/2, then the sine of negative pi over 6 is 1/2. So now it's as if we're saying, let's take the tangent of negative pi over 6, right? Working from the inside out, that's going to be, if we remember our values, negative root 3 over 3. So there we go. The arc tangent of the arc sine of negative 1/2 is negative root 3 over 3. And this last one, let's talk about the arc tangent of the cosine of pi. We know that the cosine of pi is equal to negative 1, right? Cosine of pi is equal to negative 1, right? That's one of our basic values. The cosine of pi is equal to negative 1. So it's like we're taking the arc tangent of negative 1. So what we need is an angle between negative pi over 2 and positive pi over 2, not including either of those endpoints, whose tangent would be negative 1. So let's think about that for a minute. What angle would that be? Well, one springs to mind right away, negative pi over 4. There it is, right? The tangent of negative pi over 4 would be negative 1, and so the arc tangent of the cosine of pi is negative pi over 4.